Hey, what's going on, everyone? So I wanted to cover some of the material in this week's reading. So this is going to cover algorithms and flowcharts, and of course, the algorithm is the solution to our problem prior to writing the code. So I believe that I've mentioned this before, but our algorithm is going to be in pseudocode. So, and that's rather than C. So that algorithm is the step between the analysis and the code. So we analyze the problem, come up with a solution of the problem, and then the pseudocode is going to be our algorithm to solve that problem, and then the algorithm is translated into the higher level language a little later on. So we're going to get into the algorithms and get into a little deeper into the pseudocode and our syntax that we are going to use in this class. And again, we're going to presume that all of us are part of a single software development team. So that means that all of us have to use the same syntax, the same formats, and all that. So it's easier to for those discussions during our meetings to discuss the solution to our problems. So an algorithm is an ordered sequence of steps that results in a solution to a predefined problem. So again, during the analysis, we define clearly what the problem is going to be, and potentially break those down into smaller problems to ultimately solve the main problem. So that will lead into our sequential control structure. We'll get into that in a few more minutes. And once again, this class focuses on algorithms. So our algorithm is going to be pseudocode, so get familiar with our syntax for pseudocode. So some of the characteristics that our reading discusses for algorithms is finiteness, which means that it has a finite number of steps, meaning that when you run that program, it has a maximum number of steps that it's going to perform. Now, it may produce fewer steps depending on some of the control structures that we use. Like, for instance, if we use if-then else statements, if it never even enters the if statement, then it's not going to do the then or the else. There's also definiteness, which means that there's no ambiguity in each step, and that means that each step is going to do the same precise thing every time, and that gets into the commenting and documenting our code properly to make sure that we clearly identify what each step is going to be doing. So when you go back to that code in a year, or someone else looks at your code, they know precisely what the intent of each of those control structures are supposed to be. And then you have input and output, and the input must be predefined as well as the output. Sometimes a module or a program may not have any input. It may only produce output, depending on how the code is designed. And the output, it must have at least one output. It can have more than one, but now don't be confused with the idea that each module is going to have one entry and one exit. You can have one exit and still have multiple outputs from a module. And then, of course, the effectiveness. It must resolve the problem that was defined in our analysis phase. So, and again, our algorithms are going to be depicted in our pseudocode. So get familiar with that. Some of the advantages of algorithms and the products that they provide is that it's a step-by-step solution and easy to understand. It's also easy to debug because we have that modular design. We also have them commented properly to determine what each step is doing. And I've mentioned this before, but it's very important that we understand that this is language independent. So our pseudocode we'll be able to translate very easily to whatever higher level language that we're going to use in that coding phase. So it will translate to C++ or to Java or to C or whatever. But it's very important to understand that this is language independent. Now, I certainly I admire the motivation for a lot of the students to write some of their code in C. That's great, but we can't focus on a specific programming language because this our algorithms should translate into many higher level languages. And again, that's one of the advantages of using pseudocode, is that it is easily translated into that higher level programming language. So back to our control structures. If you remember, over the last couple of weeks we talked briefly about this, and there are sequential control structures that follows one command after another, and then there is a selection control structure that's based on the state of a certain condition or number of conditions, and we'll talk about that here in just a few minutes. And there's branching, which if any of you have ever taken basic programming in high school or whatever, you know what a go-to statement is. Don't use go-to statements, because that loses control of our code and it goes to a different location without executing some of the commands that we have but beneath the go-to statement. Looping is going to be a very, very important control structure that we'll focus pretty heavily on. This executes a set of statements or set of commands for a defined number of times. So it could be 1 or it could be 1 million, but we'll get into that here shortly. So in just about every program we have to make decisions, and we can use if-then statements or if-then else statements. That should be if-then else, not if-the-else, and case statements. So we'll take a look at that and see how this works. So the standard if-then else statement is, if a certain condition is true, then execute the commands inside those brackets. And if the condition is false, then it's going to execute the commands below the else statement. So that means that it's going to either do this statement in the if portion or this statement in the else portion. Now, you don't always have to use the else statement. You can just use the if statement. So if you're looking to test for a certain condition and produce an output, if that condition is true, then you could just use the if-then statement. And then there's a case statement, which is very similar to the if-then-else, but you have more than two conditions that you're looking for. So in this case, we declare our variables. We have declare case choice as a character, and remember from one of the previous videos that character variable can only hold one character. And then we declare case price as float, and of course, since that's going to be a price, it has to be a floating value, because there's a potential that it could be a fractional value. And then we're going to give instruction to the user saying make your selection by entering A, B, or C. And then you'll notice again this variable for case choice is a character, so it is only going to hold one character. So the user will enter A, B, or C, and if it's A, then it's going to set the float variable of case price to 89.99, and it's going to break out of the case statement. Likewise, if the value in case choice is B, it's going to set the variable case price to 109.99, and it's going to break out of the case statement. And same thing for case value of C, is going to set the case price to 239.99 and break. Or if the user entered some other value besides A, B, or C, is going to say you entered an invalid option. And then every case statement has to have an ending statement saying end case. And we'll talk about those a little bit more later on. And there's looping statements, and there's several different types of looping statements. There's a while do or do while that that test a condition. Again, all these looping statements depend on the state of a specific condition, and if the condition is true, then it's going to go into the brackets and execute the contents of those brackets. And again, inside those brackets, it could be one statement or it could be 50 statements. It just depends on the code. And then beneath that, it's going to say do. And now with the do while, it's configured the same way, but the do is up here, and then the while is down here with the condition. So the difference is, but if you have the do while, it's always going to go into that condition before it tests whether it's true or not. So it's always going to execute the guts of those brackets before it tests the condition. So be aware of that and make sure you understand how that works. So this is probably one of the most important looping control structures or repetitive control structures that we need to understand. So pay very close attention to how this works. Now, I apologize, but this doesn't have the declare statement above that. But of course, you'll have to have a declare statement to declare count as an integer, and then inside the for loop, there are 3 different phases inside the for loop. The first phase sets the value of the variable count to 0, and then the next phase, it tests whether the value of count is less than or equal to 10, and then it adds 1 to the value of count. Now pay attention to what happens with this, because as we enter this for loop, the value of count is going to be 0, and then it's going to execute the guts of this of the for loop. And again, the guts of the for loop could be 1 statement or it could be 100 statements. So on the first pass through the for loop, the value of count is 0. So then when we finish the for loop, we go back up here and we increment the value of count by 1, which is what the count plus plus does. That's the very same as saying count equals count plus 1. So now this count equals 0 never gets hit again while it's inside this for loop. But it increments that to 1, executes the guts, and comes back up here and says, okay, is count less than or equal to 10? And right now it's 1, so it is less than or equal to. So it does that 10 times, and notice that on the 10th time, the value of count is actually going to be 9, because we started at a value of 0. So at 9, it's still going to execute that the guts of that for loop one more time, and then come back up here and increment it to 11, and it's, of course, count is going to be greater than 10 rather than less than or equal to. So it's not going to execute that. It's going to go down and start executing the code beneath that for loop. So it's very important that you understand that, and we'll get more into that later on. But this is a really critical control structure, the repetitive control structure that we'll use throughout this course. So we get into flowcharting, and the text in our reading modules have covered some of this briefly. But our flowcharts show the flow of processing, and it helps with our algorithm design, and it also helps convert that algorithm or the pseudocode into our high-level language. So there are symbols listed in the Week 2 online modules for the pseudocode. Let's take a look at those real quick. Okay, so these are the basic symbols that we're going to be using in our pseudocode. We have a terminal, which is it shows the beginning and the end of our program, and these are processes, which is effectively the calculation of values or assigning values to a specific variable. And input and output is when you have input coming in from the user, or something being displayed out to the user on the screen, what have you. And the decision-making processes is very similar to it's the if-then-else statements that we discussed earlier. It can also be a case statement. Now the case statement is going to look a little different, but that's what that decision symbol is for. And the predefined process, we're not going to use that very much in this class. You can use that if you'd like, but that's kind of a group of statements that are bundled together rather than using a series of the basic processes. And the connector is if you have a flowchart that is quite long and you need to fit all that on one page, you can put a connector down at the bottom and put A inside the connector, and then put the remainder of the flowchart at the top, and continue the flowchart from there. And of course, there are arrow lines that connect all of the symbols from your flowcharts, and those are also used in the looping statements. And we'll talk about that more here in just a sec. So as we've talked about before, there are three basic types of control structures: sequential, decision, and structure, and we've talked about some of those already. This is the sequential control structures that we'll see in our flowcharts. So you have statement 1, statement 2, and statement N, and remember that those are processes that are taking place in the code in our flowchart. That's rather than having input or output, because the input and output look a little different. So these are the decision-making structures that I spoke of, and the flowcharts that we'll be using to depict those. So this on the right side is a basic control structure for an if-then-else statement and how that's going to look. And if the condition is true, then you execute the then statement. If the condition is false, then you execute what is contained in the else statement. Now, remember that the if-then-else statement may have only an if-then condition. So if that's the case, then the no arrow will come straight down at this point and go into the next process. Now, this is the case statement, and I posted a link out there for a flowcharting utility called Raptor. And Raptor is not a bad application. Actually, it's kind of cool because you can, when you put your flowchart together, you can actually execute your code and see it work. But the problem with Raptor is that it doesn't capture a case statement very well. Actually, it doesn't do it at all. So if you choose to use Raptor in an area where you have a case statement, you'll have to use a series of if-then statements to make the case statement work. But the case statement basically takes a condition, and rather than having two possible conditions where it's yes or no, you have multiple conditions. So that's so if it's case 1, then it goes to this process, case 2 to this process, and then on to the next process in the code. And these are two types of looping structures. This is repeat until and then while do. But our for loops are going to be very similar to this, and basically it will continue to loop through these structures as long as that test condition is true. Now, with looping structures, you have to be very, very careful, because if you enter a looping structure, regardless of whether it's a for loop or a do while or what have you, there's a potential that condition that's testing for will always be true. So if that's the case, you're stuck in that loop forever. It's an infinite loop. So you'll have to pay very close attention to your code, make sure that that kind of thing doesn't happen. So we talked briefly about flowcharts and control structures and making decisions, um, and the relational logical operators we talked about a little earlier. Now the hierarchy of operations, that's we talked about that a little bit last week. That's when you're doing the mathematical operations and combining that with the logical operators and the like. There's a certain sequence of events that happens that, and I believe that I provided that in one of the previous videos. Okay, and that's pretty much all that I have on the week 3 material. I'm sure that that there's something that I've missed, and if there is, please let me know, and we'll cover that in the discussion during week 4. I'm sorry, during week 3 rather. So let me know if you guys have any questions, and I appreciate it.